Alright, so let's get started with 5.6. And 5.6 is the fundamental theorem of algebra. So this core concept, make sure you write it down. We will refer back to it, or you will refer back to it whenever you do these notes. But it may not be easy to understand. It'll be a little easier to understand as we go through the problems. So the theorem for the fundamental theorem of algebra is if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. So then the corollary for that is if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x has exactly n solutions, where this one said at least one solution, has exactly n solutions provided each solution repeated twice is counted as two solutions. So on that, if each solution repeated twice is counted as two solutions, each solution repeated 3 times is counted as 3 solutions, and so on. So what that means is if you have something, and we'll look at it here in just a second with an example, it'll make more sense. But if you have something that looks like x plus 3 cubed equals 0, well, you're first going to take the cube root of that and get x plus 3 equals 0, and then subtract 3 from both sides to get x equals negative 3. But since there was a cube here, that's happening 3 times. So that solution is repeated 3 times. There may also be times that you solve them separately and have the same solution happening multiple times. So just make sure and count all of those solutions individually. All right, so let's go ahead and get started here. The first one, how many solutions does the equation have? Well, remember, make sure it's in standard form. So you're going to make sure that your largest degree is at the beginning, x cubed plus 3x squared plus 16x plus 48 equals 0. And that cube, that degree right there tells us, since it is degree 3, it will have 3 solutions. So that largest degree tells us exactly how many solutions we have. All right, so let's look at the next one. How many solutions does this function have? And it's f of x, but that's okay. We can still deal with that. We would just make that 0 if we were trying to solve, but we're not. It's already in standard form. X to the 4th plus 6x cubed plus 12x squared plus 8x. Again, look at your largest power to find the degree. That degree is 4, so there are 4 solutions. And that's all there is to those. All right, so moving on here. This says find all zeros of f of x equals x to the 5th plus x cubed minus 2x squared minus 12x minus 8. We're going to find all those solutions. An easy way for us to do that is going to be graphing, and we're going to use that calculator to our advantage. So let's pull up the calculator. All right, so pulling up this calculator, all we're going to do right now is plug in that into our graph. So we are going to go to a graph screen. There we go. And now let's plug in that equation, x to the 5th plus x cubed minus, be sure you use the minus and not the negative. We've had some confusion on that. Minus 2x squared minus 12x minus 8. And we'll press enter and get that graphed. So that graph right there, let's take and draw a sketch of that graph on our paper. You do not have to use graph paper for this. This is simply a sketch. So it went away. Okay, so evidently it's going to go away every time I do that. But so right here, this is at -1, and then right here at +2 is what it appears to be. So we are going to sketch our graph. It's going to come up right there to -1. It's going to go down and come back and cross over at +2. Let's make sure that that looked somewhat similar. It's not perfect. It doesn't have to be. It's just a sketch. The only points we are worried about are that -1 and that +2. So we're finding all the zeros. Check that graph, make sure that that's where it looks like it's crossing. And then what we're going to do is we are going to use synthetic division. So let's start with -1. If we start with -1, I'm not going to write it out with long division first like we usually did, but what we are going to do is go ahead and put our coefficients of 1 in right here for those that don't have a coefficient other than 1. And make sure you put in your placeholders. So we have 1 from x to the 5th. There is no x to the 4th, so put a 0 in there. 1 for x cubed, -2 for x squared, -12 for x, and then -8 for the constant on the end. Now remember with your synthetic division, and I use synthetic division because it's faster, it's easier. If you prefer long division, you are more than welcome to use long division. Okay, so with synthetic division, again, remember, drop that 1, and then you're going to multiply. -1 times 1 gives me -1. Add 0 plus -1 is -1. Multiply times that -1, which gives you +1. Add to get 2. Multiply to get -2. Add to get -4. Multiply to get +4. Add to get -9. No, 8. Sorry about that. 8, 9, 10, 11, 12. Yep, -8. Multiply to get +8. And add to get 0. Remember that this is your remainder. If you come out with a remainder of 0, then this is indeed a solution to your system. Or not your system, but your function. So that was a correct point right there. Now, what we're going to do is instead of starting back over, we're going to take these numbers right here and we're going to do synthetic division again, but with that 2 right there. So we're going to use the 2 and we're going to draw a new synthetic division using the answers. So we have 1, -1, 2, -4, and -8. We don't need the 0 because it was a remainder. So just to put out to the side, this one was an x to the 5th at the beginning. This one will be an x to the 4th at the beginning. So we can kind of keep track of that. Now, drop your 1. Multiply by the 2 in the front to get 2. Add -1 plus 2 gives me 1. Multiply times 2 to get 2. Add down to get 4. Multiply by 2 to get 8. Add down to get 4. Multiply to get 8. Add to get 0. Again, we have a remainder of 0, so this works out as a solution to our equation. Now, since this started as an x to the 4th, we are going to start here with x cubed, but we don't have any more answers from our graph that we can get. So we know from looking at this, there's supposed to be 5 solutions here. I've only gotten 2 of them. So we're going to have to factor to find the other 3. Now, if that started as x to the 4th, again, I'm going to have 1x cubed plus 1x squared plus 4x plus 4. And we're going to set that equal to 0 so that we can factor. You don't have to put the 1s there. It's not a big deal. It's an understood one. So now, if we have 4 terms, the way we're going to factor that, remember, we're going to put them in grouping. When I group these, I'm going to drop those understood ones. So we have x cubed plus x squared plus 4x plus 4 equals 0. Now, looking at the first set, what do the 2 terms in this first set of parentheses have in common? Well, they have an x squared in common. When you take x squared out of that, when you factor out, you're basically dividing. So x cubed divided by x squared leaves me with x. X squared divided by x squared totally cancels out, but I can't just leave it blank. So when something cancels out, it reduces to 1. So I have x plus 1 here, plus 4x plus 4 has a 4 in common on both sides. So I'm going to factor out a 4. And when I factor out that 4, 4x divided by 4 leaves me with x, plus 4 divided by 4 is 1. So I color-coded those so you can kind of see what's going on there if you couldn't see that before. Write down what they both have in common, the x plus 1. And then we're going to write down what's left, which is x squared plus 4. Okay. Now, from there, we are going to set each of these equal to 0 so that we can solve. So we have x plus 1 equals 0, and we have x squared plus 4 equals 0. The first one is an easy solve. Subtract 1 from both sides, and x is equal to negative 1. The second one is somewhat of an easy solve. Subtract 4 from both sides, and you get x squared equals negative 4. We don't want no solution, but remember we can use imaginary numbers. We do need to take the square root of both sides, so the square root of x squared is equal to the square root of negative 4. So the square root of x squared is just x. But if I'm taking the square root of negative 4, remember you've got to break that down to the square root of 4 and the square root of negative 1. Well, the square root of 4 is plus or minus 2, and the square root of negative 1 is I. So really that gives us 2 answers, and I'm going to go ahead and write those separately as x equals positive 2i and x equals negative 2i. Now, what we're going to do is we're going to make a list to make sure that we've gotten all of our answers that we need. So from the bottom right here, I've got an x equals 1, I've got an x equals 2i, and I've got an x equals negative 2i. So now let me scroll all the way up to the top, and remember those 2 answers we got from the graph? Those were x equals negative 1 and x equals 2. So we're going to go way back down here and add those to our list of x equals negative 1 and x equals 2, and I have a mistake. I forgot to put my negative right here. So if you notice, you do have a repeated solution, x equals negative 1, x equals negative 1. But it told me I have 5 solutions, so let's see, 1, 2, 3, 4, 5 solutions. So this is your answer. All 5 of these written out. Make sure you make that list. The reason the negative 1 is repeated is because it doesn't actually cross the x-axis there, it touches it. So anytime you have a graph that comes up and touches the x-axis and then changes direction, you'll typically have a repeated solution there. Okay? So moving on from there, let's just do these top 2 real quick. How many solutions? It's x to the 4th, so that's going to be a degree 4, which is going to give us 4 solutions. Then the next one is x cubed. It's in standard form, so that's a degree 4, which is going to, I'm sorry, not a degree 4. I was looking at the wrong problem. Degree 3 that I highlighted, and then that would give us 3 solutions. All right. Let's do this one real quick. It's just another example like that example 2 that we can work through. So finding all of the zeros, let's plug that in our calculator. So let's pull this calculator back up. We are going to clear everything there. And if you press tab, you can pull that back up. So we have x cubed plus 7x squared plus 16x plus 12. And there's our graph. Now, you may want to zoom in on this just a little bit to see what's going on. If we go to Menu, Window Zoom, zoom in, I want to center it right at that. And I want to zoom in again and zoom in again. That way, you can make sure that whenever you draw this graph, it looks precise and you make sure you're touching or you're crossing the graph wherever it needs to. So, looking there, and you may need to trace since we've zoomed in so far, but we know it crosses on that left piece and then it touches on the right side. So now if we were to go back and zoom out, so maybe that'll kind of help us get our point because we've zoomed in really far. All right, right there, that helps us out a lot because it shows us that it's crossing at approximately -2, or touching at -2 and crossing at -3. So that's what we're going to go with. So when we draw or sketch this graph right here, it comes up and crosses, comes back down and touches, and then goes back up. And that is going to be at -3. And this, even though it may not look like it, is at -2. And that's the beauty of having a sketch. You don't have to put all of the numbers on the graph. You just put the ones that you need. Where it crosses, it's just an estimation there. All right, so let's go back and do the same thing again with the synthetic division. So 3, 2, 1, none. We don't have to put any fillers in. So let's start with our -3. And we have -3 pulling our coefficients here. We've got 1, 7, 16, and 12. So let's drop the 1. 1 times -3 is -3. Add, and you get 4. Multiply by -3, you get -12. Add, and you get 4. Multiply again, and you get -12. Add, and you get 0. So your remainder is 0. Which means that that is in fact a solution. So you started with x cubed on this one. The next one is going to be an x squared, but we're going to use these same numbers from right here. So 1, 4, and 4. But we're going to start with -2 this time. So let's drop that 1. -2 times 1 is -2. Add to get +2. And -2 times 2 is -4. Add and you get 0. So right there, that is your remainder, because this one was an x squared. So this one works because of the remainder of 0. Since this one started out as x squared, then I'm going to write x plus 2 and set it equal to 0. Well, that's the only thing. I don't have to factor anything. I just solve that. Subtract 2 from both sides, and x is equal to -2. So now I can go over here and write my list of solutions. X equals -3, x equals -2, and x equals -2. Now, remember what I said before. If it touches the x-axis instead of fully crossing, then you possibly will have a repeated solution. Well, it touched at -2, and it's repeated. So there's all 3 of our solutions. 1, 2, 3, and it's x cubed, so that one's done. All right, moving on here. Complex conjugates theorem. So we've kind of talked about this a little bit already, but if you have an A plus BI, you should also have an A minus BI. And again, if you have A minus BI, you should have an A plus BI. What that means is if you have 4 plus 3i, you should also have 4 minus 3i. We talked about this with square roots already, because we were talking about if you have the square root of 5, you should also have the negative square root of 5. So just remember that every time you're working through this next problems. All right, so looking here, it says write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and zeros of 2 and 3i. So the main thing that you need there is that your solutions that you're starting with are 2 and 3i. So here we go. We've got x equals 2. We've got x equals 3, not 3i, I'm sorry, 3 plus I. So from there, what we just said was if you have 3 plus I, you also need x equals 3 minus I. So working with that, we are working backwards now because we have all of our solutions. So we now just need to go and get the problem that goes with them. So if I were to subtract 2 from both sides here, I would get x minus 2 equals 0. Subtract 3, subtract I on both sides here, I would get x minus 3 minus I equals 0, because this right side, we're making it cancel. And again, subtract 3, add I on both sides here, so that 3 and i's cancel there. So x minus 3 plus I equals 0. From that point, remember we're working backwards, so before we were to get to this point, they would all be written together in one equation. We would have x minus 2 times x minus 3 minus I times x minus 3 plus I, all equal to 0. So when we are going to work this out, we're going to box it, and any time, and guys, please make sure you pay very close attention to this, any and every time you have i's involved, always, always, always multiply your i's together first. So here I'm going to have x minus 3 minus I and x minus 3 plus I. I'm going to go ahead and draw an arrow for this. This is going to go way on down here. We're going to catch up with it in just a minute. But for right now, let's multiply here. X times x gives me x squared. X times negative 3 is negative 3x. X times negative I is negative xi. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Negative 3 times negative I is positive 3i. Positive I, positive x is positive xi. I times negative 3 is negative 3i. And I times negative I is negative I squared. But remember, I squared is negative 1. So I have negative 1, which is positive 1. So let's take that and write the answer for that here. So we have x squared. That one's done. Then, like terms, we have our x's. So negative 3x and another negative 3x will be negative 6x. Then, if you look carefully, xi, negative xi, they cancel each other out. Negative 3i, positive 3i, they cancel each other out. Then I have 9 and 1, which is going to give me 10. So plus 10 here. I'm going to put that in parentheses. It is equal to 0. And then earlier we said we're going to drop down the x minus 2 and come back to it later. Well, it's later. So we have another box set up. Let's plug these things in. X minus 2 and x squared minus 6x plus 10. Go ahead and multiply those out. So now you will have x cubed. X times negative 6 is negative 6x squared. X times 10 is 10x. Negative 2 and x squared is negative 2x squared. Negative 2 and negative 6x is going to give you 12x. Negative 2 times 10 is negative 20. So write your answers from that. We have x cubed, which was from here. Like terms, look at your x squareds. So we have negative 2 and negative 6, which is going to be negative 8x squared. Then we have our x's. We have 12 and 10, which is going to give us a positive 22x. And then on the end, we have our minus 20. So that is going to be negative 20 equals 0. It said to write it as a function. So we have f of x equals x cubed minus 8x squared plus 22x minus 20. And that is our answer. And then it's a third degree because we had 3 solutions. Okay, so now let's look at a couple more. We're not going to work these out completely. I just want us to look and see what kind of solutions or how many solutions, what they look like we're going to have on this before we work it all the way out. So on number 5, it tells us again, just like the last problem, write a polynomial function, leading coefficient 1, given zeros, least degree. So right here, we're given negative 1 and we're given 4i. So if we're given 4i, then we need to have negative 4i there as well. Number 6, and we're not going to work the whole rest of this problem. To work that, you would refer back to the previous problem that we worked out. And I'm just trying to save a little bit of time there by doing that. So on this problem here, on number 6, you have a solution of 3, and you have a solution of 1 plus I square root of 5. So the other solution that you would need is 1 minus I square root 5. And you can work with those. On number 7, you are given square root 2 and then 1 minus 3i. Well, since you have the square root of 2, you also need the negative square root of 2. And since you have 1 minus 3i, you also need 1 plus 3i. Okay? And number 8, the last one that we'll look at as far as what the solutions are supposed to be, you have 2, you have 2i, you have 4 minus the square root of 6. So with the 2i, you'll also need negative 2i, and 4 minus the square root of 6, you'll need 4 plus the square root of 6. Okay, so again, like I said, we're not going to totally work those out. If you need help with working more of those out, then just get with me at another time and I will help you with that. But you do have one example just right before this that you can refer back to. Okay, so now let's look at Descartes' rule of signs. Basically, this is just saying that if you're looking at the number of positive real zeros, you can figure that by the number of changes in the sign of the coefficients. So it is either that number or less than that number by an even number. So if I'm counting sign changes and my signs change, let's say, 7 times, well then I could possibly have 7 solutions, or less than that by an even number. So I could have 7, I could have 5 because I subtracted 2, I could have 3 because I subtracted 2, or I could have 1 solution. And that's just looking at if there were 7 sign changes. If you had 10 sign changes, then you could possibly have 10 solutions and then subtract 2 each time. So you could have 8, 6, 4, 2, or 0. Now, also on this same note, the number of negative real zeros is equal to the number of changes in the sign of the coefficients of f of negative x. So you're going to be counting the same way, and it's or less than this by an even number. So you're going to be counting it up the same way, except we're going to have to mess with the equation by multiplying by a negative. So let's look at all of that. Determine the possible numbers of positive real zeros, negative real zeros, and imaginary zeros. We'll look at imaginary. We didn't talk about that yet, but we'll look at that in this example. So for this one right here, let's count sign changes. So I start out with positive, and it changes right there to negative. That's one change. Then it goes back to positive right there. That's two changes. It goes back to negative right there. That's three changes. And then here it's negative, 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 negative. It doesn't change anymore. So I have three sign changes in my original function. Not charges, changes. Okay, so if I have three sign changes, that means that I could have 3 or 1, because you always subtract 2, 3 or 1 positive solutions. Or we'll say zeros, since that's what they asked for. Positive real zeros. That's how it's worded in the problem. Now, to find the negative, you are going to take f of negative x. So for every x, we are going to plug in negative x. So we have negative x to the 6th minus 2 times negative x to the 5th plus 3 times negative x to the 4th minus 10 times negative x to the 3rd minus 6 times negative x squared minus 8 times negative x minus 8. So we are going to work this out. It's not a lot. Just remember, a negative raised to an even power comes out positive. A negative raised to an odd power comes out negative, and then we have to multiply. So negative x to the 6th is just x to the 6th. And then we have negative 2 times a negative to the odd. Negative to the odd power, negative to the 5th power, is negative. Times that negative is positive 2x to the 5th. Negative to an even power comes out positive, times positive is positive 3x to the 4th. Negative 10 times a negative x to the 3rd, so to an odd power, that's going to come out negative, and then when I multiply by negative 10, I get positive 10x to the 3rd. Negative x squared comes out positive, times negative 6 is negative 6x squared. Negative 8 times negative x is positive 8x, and then negative 8. So let's go through there and count sign changes. This is f of negative x, so positive, to begin with, positive, 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 negative. There's my first sign change. And then it goes back to positive, there's my second sign change. Back to negative, there's my third sign change. So if I have 3 sign changes, then I could have 3 or 1, because remember you have to subtract 2 every single time, negative real zeros. Now it said something up there about finding the imaginary zeros, which as you can tell, there's a little table below that. So we are going to plug all of this into that table. So on the positives, we could have had 3 positive real zeros. We could have also had, and there's a reason I'm skipping this line, you'll see in just a second. Yeah, let's go all the way across. If we had 3 positive real zeros, and we had 3 negative real zeros. Well, let's see how many total. If we look back at the very beginning, we have a total of 6 zeros because the degree is 6. So if my total has to be 6, if my total has to be 6, and I have 3 positive and 3 negative, how many imaginary does that leave? Well, it leaves 0 imaginary. If I had 3 positive, the other option for negative was 1. So if I have 3 positive and 1 negative, and a total of 6, well, this is 3, 4. That's only 4 of my solutions. That means I could have 4 imaginary. So now, what if, because I only have 2 options for negative, I also had 2 options for positive, 3 and 1. So now if I put in a 1 right there, I could go back and have 3 negative. So 1 and 3 gives me only a partial. You know what? I did something wrong right there. That's not supposed to be a 4. Our total is 6. So on both of these, I have 4 total. I have 2 left over. Sorry about that mistake. So you have 2 imaginary zeros on both of those. We have one more possibility. We could have 1 positive and 1 negative. With a total of 6, if I have 1 positive and 1 negative, that's only 2 of my 6 solutions. So that would leave me with 4 imaginary solutions. Now then, this table right here, this entire table, is your answer, because that is what generates how many imaginary solutions you have, even though you've already figured out how many positive and negative. So you're going to have to make sure that you make that table every single time. Okay, so let's do one more of those. All right, so for the last one, we're going to look at another one of these. Let's go ahead and look at positive sign changes, or sign changes for positive real solutions. So if it starts out positive, it goes to negative, so that's 1. Back to positive makes 2. Back to negative makes 3. And back to positive makes 4. So with 4 sign changes, we will have 4, 2, or 0 positive real solutions, or real zeros. So remember, you're subtracting 2 every time. You're not going to go into the negatives, but 4 minus 2 is 2, 2 minus 2 is 0, so we have to have 4, 2, or 0 on that one. Now then, to find the negatives, remember, you're just going to plug in negative x, so we have 3 times negative x to the 4th minus 7 times negative x to the 3rd plus negative x squared minus 13 times negative x plus 8. So we have f of negative x is equal, now negative x to the 4th, 4 is an even, so that is going to come out positive. So we have 3x to the 4th. Negative x to the 3rd will come out as a negative, times a negative is positive 7x to the 3rd. Negative x squared comes out positive, so we have positive x squared. Negative 13 times negative x is positive 13x, and then we have plus 8. So if we look through this, starting with a positive, 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 we have 0 sign changes. Well, if we have 0 sign changes on the negative part, then that means we are going to have 0 negative real solutions, or real zeros. Remember, solutions and zeros are the same thing. So now, let's go down to this table. You may or may not always know how large to make this table, but on the negative, it's always 0 because that was our only option. So we're going to fill that all the way in. And our total, since we had 3x to the 4th, our total will be 4 all the way down. Our possible answers for positive real zeros were 4, 2, and 0. So if I have 4 positive, 0 negative, and a total of 4, that leaves me with no imaginary. If I have 2 positive, 0 negative, and a total of 4, I've got 2 left over that can be imaginary. And if I have 0 positive and 0 negative, all 4 of them are going to be imaginary. And once again, this entire table is your answer for that problem.